This is a lesson over equations of lines in a coordinate plane. So the objective, students will be able to write an equation of a line given the slope and the y-intercept and given 2 points. So if you look at this objective, it is very much an Algebra 1 objective. In Algebra 2, if you had that last year, we also did this a lot in Algebra 2. So hopefully this is a review for you guys. Obviously, I'm not just going to skip it and assume that you know it, but hopefully when you see it, you remember most of this. The stuff you don't, hopefully it's easy to pick up on. So the slope m of a line is the ratio of the vertical change to the horizontal change. That's the rise and the run. The rise is the vertical change, the run is the horizontal change. And that's between any 2 points. So a line contains points x1, y1, and x2, y2. Rise over run is y2 minus y1 over x2 minus x1. Again, the rise is dealing with up and down. That's the y values. And again, the x1 and y1, they're talking about the x of your first point, the y of your first point. The x of your second point, the y of your second point. Same thing over here. So this is x1, y1. That's my first point. That's my point 2. x1 is just referring to the x value of your first point. y2 is the y value of your second point. So what's the slope of this line? So there's really 2 ways to do this. If you have a graph, you could do the rise over the run. And that just means count how much you go up. So if we start with this point, we go up 1, 2, 3, 4, 5, 6. That means we go up 6. And over to the right, 1, 2, 3, 4, 5. Now, since I went up, it is positive, and when I went to the right, it's positive. Now, I always start with the point that's on the left. I think that makes life a lot easier. I could explain why, but I don't really want to get into it and take a lot of time. Just trust me, I think it's easier to go on the left. But if you start with the point on the right, that's fine. That just means your rise is down 1, 2, 3, 4, 5, 6. So since it's down, it's negative. And then you go to the left, 1, 2, 3, 4, 5. And since to the left, it's negative. Negative over negative is a positive. So it's really the same thing. I just think it's a lot easier to always start with the one on the left. For what it's worth, if you always start the problem on the left, or the point that's on the left, then your denominator will always be positive, and I think that's easier, but that's okay. It doesn't make much difference, as long as you remember that. Now, the other thing you could have done with that one is you could have looked and saw that they gave you the ordered pairs, so you could say this is x1 and y1, and x2 and y2. Now, it doesn't matter which one is your point 1 and point 2. You could have made 3, 5 x1 and y1. That's fine. You just have to pick it and make sure you're consistent. So if this is your point 2, they both have to be 2, x2 and y2. If this is your point 1, they're both x1 and y1. So then y2 minus y1 over x2 minus x1. Y2 is 5 minus negative 1 over 3 minus negative 2. Now, if I were you, I would just put that in my calculator. 5 minus negative 1, 3 minus negative 2. That way you don't have to worry about any fancy things. But if you do it by hand, minus negative is a plus. So that's 5 plus 1. And 3 plus 2 minus negative, so that's 6 over 5. Now, again, if I were you, I wouldn't worry about minus negative makes a plus or slash and dash, whatever you want to call it. I wouldn't worry about that. I would just put this in my calculator. 5 minus negative 1, 3 minus negative 2. So what about this one? This is what's the slope of the line passing through these points. So you don't really, since you don't have the graph, it's a lot harder to just count how much you go up and how much you go over. So this is where I'm going to make my point 1 and 2. Again, it doesn't make any difference which one you make which. That's my point 1 and 2. So I label them like that a lot, and that's just how I leave it because I think that's easy, but it's not a bad idea. I'm going to encourage you guys to label. This is the x value of my point 1. This is the y value of my point 1. Now, I can't write on this part of my board very well, so this might not match up. This is my x2 to 7, and then y2, I can't reach that 2 because my board ends, but that 2 over there is the y2. So if you do the formula, y2 minus y1 is 2 minus negative 6. And then x2 minus x1, 7 minus 4. 2 minus negative, again, I would just put that in my calculator. That's 8. 7 minus 4 is 3. Again, the thing that people miss a lot with this is whether it's a positive or a negative. If this was 4 minus 7, a lot of people say it's 3. That would be negative 3. So again, I would just use a calculator. That's just the easiest way. Last but not least, make sure you're reducing these fractions. I do want you to reduce those, if at all possible. So find the slope of a line that passes through this. Again, same thing as before. I'm going to call this my point 1 and point 2. It doesn't make any difference which one you make which. I just always make the first one point 1 because I don't want to think about it. I've had people that spend 5 minutes trying to figure out which one would be the best one to make point 1 and point 2, and they could have just done the problem then done by then. So y2 minus y1, x2 minus x1. Again, just use your calculator. 1 minus negative 2, that should be 3, because again, minus negative is plus. 4 minus negative 2 is 6. Again, please make sure you're reducing those. For what it's worth, if you ever want to reduce these, if you don't know if you can or not, if you put them in those yellow calculators, 3 divided by 6, it usually gives you the fraction. Or you can hit, if it gives you the decimal, you can hit this button that gives you a fraction. But there's also a way you can type in a fraction to that calculator. It's like, I think it's a button that says n over d maybe. But if you type in 3 over 6 as a fraction, just hit enter, it'll reduce that for you. So make sure you're always remembering to do that. So these, again, just practice. Point 1, point 2. So that's x1, y1, x2, y2. Negative 6 minus 5 over 3 minus 2. Negative 6 minus 5, a lot of people mess this up. And again, it's all because of the negatives and positive signs. So just type that in your calculator. Negative 6 minus 5 is negative 11. 3 minus 2 is 1. So that ends up just being negative 11. Remember, if it's ever over 1, just the numerator, negative 11. So we have x1 and y1, x2 and y2. We have negative 8 minus 1 over negative 5 minus negative 2. Negative 8 minus 1 is negative 9. Again, I know a lot of people have put negative 7 for that, so be careful. Negative 5 minus negative 2, there's a lot of negatives in there. Use your calculator. Just type out negative 5 minus negative 2. It'll give you that answer. If you do it by hand, minus negative is plus, so negative 5 plus 2 is negative 3. But again, you don't have to worry about that. Just type it in how you see it. The negative 9 over negative 3 ends up being positive 3 when you reduce that. I guess you could say negative 3 over negative 1, which would make it positive 3, either way. So what about lines that have a 0 slope? So find the slope of the line that passes through the points negative 2, 4 and 2, 4. So negative 2, 4 is right here, and positive 2, 4 is right here. So the line looks like this. Find the slope of that line. Well, if you try to do the rise over run, it's really hard because the rise, you don't go up any, and then you go over 1, 2, 3, 4. So 0 over 4, if you put that in your calculator, it is just 0. 0 divided by 4 or 0 over 4 is just 0. So that's the slope of a horizontal line is 0. And you could also do the, again, x1, y1, x2, y2. 4 minus 4 over 2 minus negative 2 is 0 over 4, which again is just 0. So as shown in the figure, the line through the given point is horizontal. So the reason I put that horizontal, I put that O really big, is because that's how I remember that a 0 slope is horizontal, not vertical. A 0 slope is horizontal. Now the other thing, a lot of people miss this because they say it's undefined, and we'll talk about that in a second. But the way you can tell is put it in your calculator. If you put 0 over 4 in your calculator, it will tell you 0 is an answer. So put 0 divided by 4, it will give you the answer of 0. If you put the other way, 4 divided by 0, so put 0 in the denominator, it will give you an error. And probably say undefined with it. You can always use your calculator to double check that. If 0 is in the numerator, the slope is 0. If it's in the denominator, it's undefined. So if it is a 0 slope, it is horizontal. Undefined slope. So now we have 3, 2, 3, negative 4. So I have this line here. Sorry, I kind of missed it down here a little bit. Actually, I'll just redo this. it up again. Okay, so this one is a vertical line. It's a vertical line. If you look at this, what's the rise over the run? Well, if you start with this bottom point right here, I go up 1, 2, 3, 4, 5, 6, so up 6. Then I don't go left or right any, so 6 over 0. Again, put that in your calculator. It's not 0, that gives you an error. That's the undefined. And again, if you do it the longer way, -4 minus 2 over 3 minus 3, that ends up being, this was -6 over 0, which again is undefined. Now, I remember when I student taught in a middle school, there was somebody that said the way they remember it is because if you were a little guy and you were walking on this, that's fine, you could make it. But if you were a little stick-figure guy trying to walk on this one, you would fall. You couldn't walk on there. It's like walking on the side of a wall. You'd fall and you would be undefined. So if that's how you remember it, again, horizontal has an O, which means its slope is 0. Vertical, again, you could think of that, the V maybe kind of goes up and down a little bit. I don't know. I was just trying to figure out ways you can remember it. But I like that idea with the O. That works really well. And this little guy falling, making him undefined is kind of a clever way. Again, whatever makes you remember it. Undefined slope is vertical. 0 slope is horizontal. So then a couple other ones we can look at. If your slope, as you go from your left to your right, if it goes up, that means it is a positive slope. As you go from left to right, if it's going down, that's a negative. And we just talked about this. If it's horizontal, it's a 0 slope, or I guess I should have put the number 0. And if it's vertical, it's undefined. Now, this is really good, especially with positive and negative, because you can check your work really quickly just by seeing if it should be a positive or negative. I know a bunch of people that would have gotten some extra points, not a lot, but a couple extra points on tests just by seeing, well, this says it's a positive slope, but I drew a negative one. So the slope intercept form of an equation of a non-vertical line is y is equal to mx plus b, where m is the slope, b is the y-intercept. This is something you guys should all know from Algebra 1, and like when I say you should know it, you should be really, really good at this. This is the one we use the most in Algebra 1, and in Algebra 2 for that matter. So what's the slope of the y-intercept? Y is equal to -5x plus 6. This is something you have to get correct. This is the easiest thing. The slope is -5. The hardest part about that, make sure you don't include the x. The x does not go with the slope. The x is something different. Then the y-intercept is the 6. I might start writing it, the y-intercept, as an ordered pair is 0, 6. I don't care which way you write it. I know in Algebra 2 we did it as 0, 6, but I also don't mind putting it as 6. So the way you're going to graph these is you first graph the y-intercept. So the y-intercept right here was 6. And then from here you do your slope. And remember, your slope is a rise over run. Remember, if you don't have a denominator, just 1, that means we go down, since it's negative, 1, 2, 3, 4, 5, and over to the right 1. Once you have your 2 points, we connect that to make our line. Now remember, if your slope is down 5 over 1 to the right, remember that's the same thing as if you go up 5, 1, 2, 3, 4, 5, and over 1 to the left. See how that's the same line. Now this one, the slope is x over 3. Remember, if it's ever x over 3, that's the same thing as 1x over 3, which is just 1/3. So make sure you don't, for the slope, don't put 3 and don't put x over 3. The slope is 1/3. And your y-intercept, since it's a -3, your y-intercept is -3. So start with your y-intercept, and then your slope is up 1 over 3. So up 1 over 1, 2, 3 to your right, since the bottom is positive. And again, if you go up 1 over 3 to the right, that's the same thing as going down 1 over 3 to your left. Make sure you guys remember that. You can do the opposite of both of those. So it's actually the same thing as -1 over -3. Graph the following. So 3. Now, if they have a negative in front, and this is one of the things students struggle with, you just have negative 1/2, I always put it with the numerator. If you want to put it with the denominator, that's fine, but do not put it with both. If you put it with both, it's wrong now. So if you ever have a negative out front, I always just put that with the numerator. Sometimes I even do this where I put a plus sign and then put the negative to the numerator. So that means from your y-intercept, I go down 1/2 to the right, down 1/2 to the right, or again, you could go up 1/2 to your left. It's the same thing. You get a nice negative slope. And this one, -3 is the y-intercept, and then 2, so remember that's 2/1. You go up 2/1. Again, that same thing is going down 2/1 to your left. That's all that same exact line. Writing equations of the line given the slope of the y-intercept. So what's the equation of the line with a slope of -3 and the y-intercept of 5? Well, the slope is your m, the y-intercept is your b. So y is equal to mx plus b. M is -3, b is +5. So y is equal to -3x plus 5. Don't make that harder than it is. Slope is 5/3 is what that should say. Y-intercept is -9, so y is equal to 5/3x minus 9. Y is equal to 3x plus 6. Y is equal to 1/2 x minus 5. Don't forget your x's. That's the thing that most people miss when they miss this one, is they just put y is equal to 3 plus 6. If there's no x, that doesn't work. So make sure you remember that x in there. But again, should be pretty straightforward, especially after Algebra 1 and Algebra 2, or Algebra 2. So if they give you 2 points, the only difference is the first thing you have to do is find your slope. Once you have your slope, then we'll be able to work backwards and find your y-intercept. So this is going to be my point 1 and my point 2. That's x1, y1, x2, and then again, I can't really reach my y2 to label that one over there. So we have -2 minus -4 over 4 minus 4. So again, put that in your calculator, especially because there's negatives. That ends up being +2/0, which means this slope, if it's over 0, is undefined. Well, hold on. I made a mistake, and I'm glad I did. I'd like to act like I did it on purpose. It's not 4 minus 4, it's 4 minus -4. So the denominator should have been 8. Sorry, 4 minus -4 is 8, so that is 1/4. Now, honestly, the way I caught that is because you will have some problems that give you an undefined slope, but it doesn't happen very often. So if I ever get an undefined slope, I always check my work just in case. Sometimes you'll be right, but this time I caught my mistake. So that is my slope. That's the first one. So this is where you're going to have a couple different ways you can do this. So this way, you can pick either of your points and substitute it in for your y-intercept, or sorry, for your slope-intercept form. So when you do that, if you pick that, let's do the second one because I think that'll be a little easier. 4, -2. Remember, that's your x and your y. So if we sub that into, your y is -2. Your slope, we just said, was 1/4. And the x is 4. And plus, we don't know what the y-intercept is. So once you have this, now you can solve for your y-intercept. So that's -2 is equal to 1/4 times 4 is 1, plus b, minus 1. So I get -3 is equal to b. So my y-intercept is -3. And now you substitute it in again with your slope that we started from this one and your y-intercept. So we have y is equal to, my slope is 1/4 x minus 3. So that's one way to do this problem. That's what a lot of people teach. The thing I don't like about that, there's 2 things. One thing is I don't like how you plug numbers into the slope-intercept form, and then you have to do it again, but you don't sub the numbers in the same. The -2 and the 4, you don't sub it in the second time. So if you want to do it that way, that's fine. Just be careful. The other thing is this number worked out really nicely where 1/4 times 4 was a nice even number, a nice whole number. It wasn't a fraction. But if it's not like that, it doesn't work out all the time. So the way I encourage people to do it is to use point-slope form. Y minus y1 is equal to m times x minus x1. So we have y minus, and y1, we'll just use this point over here. Y minus negative 2 is equal to my slope is 1/4 times x minus 4. So it's y plus 2 is equal to 1/4 times, oops, sorry, 1/4, not 1/2, times x minus 4. Now, I don't like this fraction 1/4, and so to get rid of that fraction, I'm going to multiply everything by the denominator. So I'm going to multiply everything by 4, but what that does, this side gets multiplied by 4, this side does. So that 4 over here distributes, so that's 4y plus 8 is equal to, over here, that just cancels out the denominator. We don't multiply that 4 by this parentheses at all. All we do is multiply the fraction. So the 4 is canceled, so we just have 1 times x minus 4, which obviously is just x minus 4. And then you solve this for y. Just get the y by itself, get it in slope-intercept form. So subtract 8, 4y is equal to x minus 12. Then divide everything by 4. Y is equal to 1/4 x minus 3. Now, I don't care which way you do it, you get the same answer. I know that second way, it seemed like it was a little bit longer to do, and that's why some people don't like that way. But I like that second way because it works for all of them really well. It doesn't matter if you end up with a messy fraction for your x and y intercept over here. It works for a lot of them, I should say, maybe not all of them. So I'll probably do it both ways for a lot of these just to get you guys to practice. If you like one way better than the other, you can fast forward the other one. I don't care. But again, be really careful. If you use this first way, a lot of people put their answer as y is equal to 1/4 times 4 minus 3, and that's wrong. We need an x there. So that's one of the things I'm worried about. So let's do the same thing with this one, x1, y1, x2, y2, sorry, kind of over there. So the first way I'll do it is the same way with the slope-intercept form we talked about. So we have -4, y2 minus y1. So we have +4 minus -4 over -1 minus 3. So that's 8 over -4, which is just 8 divided by -4, that's -2 if you reduce that fraction. So we have, I'll use my first point, 3, -4 for this one. And it doesn't matter which point you use, just pick one. So my y is -4 is equal to, my slope is -2 times my x is 3 plus b. So that's -4 is equal to -6 plus b. Add 6 to both sides. I get b is equal to 2. So for slope-intercept form, we get y is equal to -2x plus 2. So that's the one way to do it. The other way to do it, and I'm sorry because I should have added some space for this, but it's using that y minus y1 is equal to m times x minus x1. That's point slope form. And again, I'm just going to, this one, I'm going to use that first point. The only reason I didn't do that last time is because they were both -4, and so that's kind of confusing. So we have y minus -4 is equal to, my slope is -2 times x minus 3. So that's y plus 4 is equal to, we'll distribute this out, -2x plus 6. Subtract 4, y is equal to -2x plus 2. So again, I don't care which way you do it. It's a little bit aggravating because I know, honestly, if you guys do it this way, it'll probably work out almost every time in this class. The aggravating thing is, in the real world, a lot of times you'll get a fraction for this multiplication part here, and that makes it annoying. And that way, this side is a little bit better if you end up with fractions there. So write the equation, slope-intercept form. Okay, so again, I'll do this. I know this is going to make the video a lot longer, but I'm going to do it both ways again. I'll probably do this a lot for you guys. So the slope, 10 minus -4 over 3 minus -4. That's 14 over 7, which is 2. So that means we have, and again, if you just want to use the first point, you can. I just usually avoided that if they were both the same number because it's hard to tell which is which. But the y is -4 is equal to the slope 2 times the x is -4 plus b. That's -4 is equal to -8 plus b. Add 8, add 8. Negative 4 plus 8 is positive 4 is equal to b. So my answer, y is equal to positive 2x plus 4. Then using point slope form instead, y minus y1 is equal to m times x minus x1. Again, I'll just use this first point here. So y minus negative 4 is equal to 2 times x minus negative 4. Y plus 4 is equal to 2 times x plus 4. Distribute your 2. Y plus 4 is equal to 2x plus 8. And subtract your 4 from both sides. Y is equal to 2x plus 4. Either way gets you the same answer. Now, I will say before I move on, if you need to go back, notice the slope for all these weren't fractions for point slope form. So if you're going to use point slope form, you might want to go back and make sure you watch this again over here, where I multiplied both sides by 4 to get rid of that denominator. And again, you always multiply both sides by whatever this denominator is. And we'll get some more practice with that in class. Or again, you can use the other way. I think a lot of the other teachers use the other method, so that's probably what you guys are going to use, but I personally don't like it as well, so that's why I do both a lot. All right, so equations, horizontals, and vertical lines. So a horizontal line has a slope of 0. Every point on a horizontal line that goes through 2, 4 has a y-coordinate of 4. If it's a horizontal line, it's going to have the same y-coordinate through the whole thing. So this is the horizontal line. Every single one of these points, if you look, the y-coordinate is 4. The equation of this line, I guess if you want to sub it in, the slope is 0, so it's y is equal to 0x. The y-intercept is 4, which means it's just y is equal to 4. So if you have a vertical, if you have a horizontal line, the slope is 0, and the equation of that line is y is equal to 4. So a horizontal line, y is equal to. A vertical line, the slope is undefined. Every x-coordinate is going to be an x-coordinate of 2, and so x is equal to 2. So that's what they're trying to get at with this one. If the y-coordinate for this one, if the y-coordinate is always 4, the equation is just y is equal to 4, because every y-coordinate is 4, so y is equal to 4. And this one, every x-coordinate is 2, so x is equal to 2. So this line, y is equal to 5. The way I always remember it is that means the y-intercept is still at 5. Well, I guess you could have a vertical line that goes through there. It just would be a little bit different, so it's probably a horizontal line. That's the way I look at it, but also, again, honestly, if you just memorize, y means it's horizontal, x means it's vertical. So the x at 5, if x is equal to 5, that means the x-intercept is 5. And again, you could just have it look like this and be horizontal. That's possible, but it doesn't happen very often. So I know that's not the best method, but it's not bad. Y is equal to 2x. So this one is a little bit of a harder one. There is no y-intercept. Well, if there's no y-intercept, that means it's plus 0. But it's not horizontal and it's not vertical because we have a y and an x. The y-intercept is just 0. The slope is up 2 over 1 or down 2 over 1 to your left. Either one works. And this one's a really good one. Y is equal to x. That means every y-coordinate, the x-coordinate's the same. So if I go over 1, I go up 1. If I go over 2, I go up 2. If I go over 3, I go up 3. If I go down 1, I go left 1. So that's a way to look at that one. Or again, slope-intercept form. The y-intercept is 0. The slope is, if it's just an x, it's 1x, which is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. Write the equation lines through 2 points. Sorry this video is long, but I want to make sure you guys remember this. x1, y1, x2, y2. Whoops. So 8 minus 5 over 3 minus 2. 8 minus 5 is 3. 3 minus 2 is 1. So that slope is just 3. So again, you could say, if you use this point now, 5 is equal to, my slope is 3 times 2 is the x plus b. So 5 is equal to 6 plus b. You subtract 6, that is negative 1 is equal to b. So y is equal to 3x minus 1. That's one way to do it. Or again, y minus y1 is equal to m times x minus x1. Y minus 5 is equal to 3 times x minus 2. Distribute that out. Y minus 5 is equal to 3x minus 6. Add 5. Y is equal to 3x minus 1. Either way works. Again, I know that blue way looks like it's a little bit more work, but it helps for some problems. X1, Y1, X2, Y2. So this one, negative 3 minus negative 3 over 9 minus 4. Negative 3 minus negative 3 is plus, so that's 0 over 5. So this slope is 0. So right away, I know it's something a little bit different. Check your work to make sure you're right. But this one's going to be a horizontal line. So if it's a horizontal line, it's going to be y is equal to something. But what's that y equal to? Well, if you look at both of these, your y is equal to negative 3. That's all you need for that. And really, you don't need both points, but both points go through negative 3, so it doesn't matter which one you pick. But that's how you do a horizontal line. If it was a vertical line, then you'd look at the x's. And again, if it was vertical, the x's would be the same. X1, Y1, X2, Y2. 4 minus negative 8 over 2 minus negative 1. That's 12 over 3, which is 4. So again, if you do it with the slope-intercept way, if you use this method, negative 8 is equal to 4 times negative 1. Plus b, negative 8 is equal to negative 4 plus b, add 4, add 4. That ends up being negative 4 is equal to b, so y is equal to 4x minus 4. Or again, you can use your slope-intercept form. Y minus y1 is equal to m times x minus x1. So y minus my y1, again, I'll just use this one, is negative 8 is equal to my slope 4 times x minus negative 1. So y plus 8 is equal to 4 times x plus 1. And again, distribute that out. Y plus 8 is equal to 4x plus 4. And subtract 8. Again, it all depends. There is pluses and minuses to both. Depending on the problem, sometimes that red way with the slope-intercept form, sometimes that's easier. Sometimes it's easier with the other way, using point-slope form. It all depends. X1, Y1, X2, Y2. So we have 4 minus 0. Sorry, 4 minus 0. Sorry, I'm trying to go quickly. I'm running out of time. 4 minus 0. So that's 4 over 4, which is just 1. So I'm going to use 0, 0 because that's an easy one. So I have 0 is equal to 1 times 0 plus b. So that's 0 is equal to 0 plus b. So that means 0 is your y-intercept. So y is equal to 1x. So technically, if you want to put y is equal to x, you can, but 1x is fine. Y minus y1 is equal to m times x minus x1. So y minus, my y1 is 0, is equal to 1 times x minus 0. So y minus 0 is just y. Then 1 times x, 1 times 0, or x minus 0 is just x. 1 times x is x. So in that case, I think that blue way is a little bit easier. Didn't have to do as much math. Now, the other thing you could do, and this is just a stretch, I know my y-intercept had to be 0 because your y-intercept is where your x is 0. So if your x is ever 0, that y-coordinate is your y-intercept then. Oh my gosh. Okay, so this is the last one. So x1, y1, x2, y2. So negative 1 minus 8 over 2 minus 2. Negative 1 minus 8 is negative 9 over 0. It's over 0. Double check. 2 minus 2 is 0, so that's undefined. So this has to be, this equation is x is equal to something. Remember, if it's undefined, that's vertical. Vertical is always x is equal to something, so what's the x? Again, it doesn't matter which point you pick because the x is the same, so x is equal to 2. Every time it's vertical, it's just x is equal to 2. And last one, we have x1, y1, x2, y2. So we have 2 minus 0 over negative 3 minus negative 2. So that's 2 over negative 1, which is just negative 2. So I'm going to use this one. So I have my y is 0 is equal to negative 2 times negative 2 plus b. So it's 0 is equal to positive 4 plus b. Subtract 4. Negative 4 is equal to b. So your answer, y is equal to negative 2x minus 4 for that one. Or again, y minus y1 is equal to m times x minus x1. So for this one, my y1 is 0. It's equal to negative 2 times x minus negative 2. So that's y is equal to negative 2 times x plus 2. Distribute that out. Y is equal to negative 2x minus 4. Again, it doesn't matter which way you do it. There are definitely some positives when you use just the slope-intercept form instead of using point-slope form. But there's also some positives doing it with the point-slope form. It all kind of depends on the problem. Honestly, yeah, it all depends on the problem and the person. Because I've seen people that try to do it this way because I think it's shorter, and a lot of times it is, but then they mess little things up where they plug things in wrong down here. So, all right. If you need any help, make sure you're sending me an email. If you need to rewatch these videos so you can really focus on which method you like to use, whether it's the slope-intercept form or the point-slope form, don't hesitate to do that.